Now that we have collected our training data, we can go to the second step. We have many steps within it. The first thing we'll do is combine the training data. So we have created 4 different feature collections for our 4 different classes. And what we need to do is combine them together so we have just one feature collection with all the points within it. Remember that we defined that class property to make sure we can differentiate the points amongst themselves, right? So we have different numbers, so class codes for each of the classes. And once we combine this feature collection, the immediate result is a feature collection of feature collections. So as you can see here, we have one feature collection object that has 4 different elements, but these elements are feature collections, which are the feature collections of our classes. So we use this flatten function here, we'll see in the code, to make sure that we have one feature collection with just features within it and not feature collections. So it's basically removing this nested feature collection, like dismantling this nested feature collection. So we will be looking to this flatten function in the code. Second, we will define prediction bands. So the model will be learning from the spectral information of our image. So we define which of the bands of our images we want to use for that, and we call that prediction bands. Then we'll sample the regions. So now that we have our points, we have here, for example, the reference data here, number 2, we have the image, and we know, each point has that class value. We'll sample the image at each of these point locations to extract the spectral information, so that the feature collection after we combine only has that property class with the class code associated with it. But once we sample the regions, these points, we'll have also the spectral information for each of that point location. And for this, we use the sample regions function, which exactly does what I'm saying, what I'm describing right now. It samples the image information at those specific points, so at these regions. Then we'll choose a classifier and train it. There are different classifiers in Earth Engine, so you can check the ee.classifier object under the docs tab. And there are many options. We'll work with cart and also random forest, but there are other ones that you can choose from. And then we'll train this classifier. So there's a function that it's called train that will use that training data to train our classifier. And finally, we'll classify the image. So after the classifier has been trained, we can classify the scene that we have chosen and see what the result looks like. Just want to briefly go through this, the cart, since we're using cart, classifier, and random forest. I'll talk a little bit about cart. So it's the classification and regression tree classifier. It is a decision tree. So what this means is that you have a start point. So for each of the pixels in your image, you have like a set of rules to be able to classify that image. So for example, this is just a hypothetical example of a decision tree. So you're looking to one pixel at a time. And then the first set of rule here is if the near infrared band value is less than 78, you classify into water. If it's greater than 78, then you have a new rule to follow. And then you have the red band. If it's less than amount of value, then you have a new set of rule. Or if it's greater than another threshold, then you have another classification. And this is very simple. This can go on depending on your classification, the classes that you want to classify. But it's basically just a set of rules. It's like a tree that in the end is making these decisions to have your final class assigned. And this is the basis for more sophisticated algorithms such as random forest. So random forest, it is basically a multitude of decision trees. So instead of just having one decision tree, random forest has more than one decision tree. And that's why it's called forest, right? Random forest, because it's many trees together. And then, so here you have, the image describing this. Here you have decision tree 1, 2, you can have 3, 4, 5, 6, you can have many trees. And each of these decision trees will make their own classification for each of the pixels. And then the final classification is based on majority voting. So if that class was elected more by the decision trees, then that pixel will be assigned that class in the end. So it's pretty much this in simple terms. And this is widely used until today for image classification. It's a very robust method. So let's go to the code checkpoint to do this step 2, complete this step 2. So exit here. I'll go back here to the code repository and I'll click on the second checkpoint, so letter B. And I'll also, while this loads, I will reset this working script. So here under resets, there's an error, and I can click clear script, and that will clear everything that I have. And I will use what Jeff showed us. So here, I'll just copy all of my points. So I clicked here on the paper icon and copied all of this. So these are the training data that we have collected. I'm gonna paste here in this new script, and I'm gonna just hover my mouse over these yellow lines and convert everything. So I have everything at the bottom there in order. So now we have a checkpoint here. And I'll copy here from line 1 through line 35. And the only new part here is here we're combining the training feature collection. So as I said, we need to combine all of these feature collections that we have created. And we can do this 2 ways. Here we are doing through just using straight the ee.featureCollection object. So it's like we're creating a new feature collection, and then we have a list of elements that we want to put inside this feature collection. And these are the feature collection names that we have there at the top. So forest, developed water, herbaceous. And remember, I have this flatten here because if I don't, so I'll just quickly remove this and do print training features, this variable. My computer is a little slow. So here, the result is a feature collection, but I have feature collections inside it. So we need to add here the flatten in order to have one feature collection with 100 elements, because it's 4 classes times 25 points each class. So we have 100 points within this feature collection. The other way of doing this, we could do, I'll just show so you know, we could do, there is a function for feature collections called merge. So we could do forest.merge developed .merge water and so on, .merge herbaceous. This would be the same thing. We're using the merge function, so the merge just combines feature collections together. So the elements within each feature collections combined. We could also do this way, just so you know. So now our variable training features has the 100 points that we use to train our model. Now I'm going to copy from lines here. I go back to the checkpoint. I'm going to copy from lines 37 through 49 and paste here. Next, I'm defining this variable prediction bands, which are the band names that I'm going to use to extract information from at the points. And I'm defining this classifier training, which will be the feature collection with the spectral information at each of the points that we will need for training the model. So first thing here, I have my image Landsat. I select my prediction bands so that we only extract information from these bands. If we don't do this, then we have those quality bands as well. If you remember from Landsat, we don't want that information. Thermal bands, we don't want that information for now. So we select just the bands that we are interested at. So we choose these bands. And then again, we use the sample regions function and say, okay, I want to sample from the training features, which is our combined feature collection. The properties, there's an argument called properties here. We define this as class, which if you remember, each of our points has a property called class with the class code associated with it. So we want to keep this information. So we have to define this properties argument. And this is a list of properties. In our case, we only have one, so it's just class. And then scale, we are working with Landsat and we define 30 meters for Landsat pixel scale. So if I were just to show, if I were to check this output, you can see that in this one, we only have one property, which is the class. But if I print this new feature collection here, this new one, if I open, for example, the first point, the first feature, it will have not only the class value, but also the spectral information that was extracted at that point. So now we have the complete training data, not just with the class value, but also with the spectral information. I'll delete this. I'll go back to the checkpoint and I'll copy from lines 51 through 71 and paste here. So now we can start training a classifier. So first we'll try with the cart classifier. So here I'm defining a variable classifier. I'm calling a ee.classifier object, and specifically it's the cart classifier. So its name is smile cart. And the first thing I need to do is train this classifier. So immediately after this, I have the train function. For the train function, I need to define a few arguments. First is the features argument, and these are the training data. It's the training data, right? So it will be the classifier training feature collection that I had just created. The class property, so we need to tell which property corresponds to the class. So here we say it's the class, named class property. And then input properties, this is the information that the model will be learning from. So we have prediction bands, which are our bands, right? We have the bands defined. So this part right here is training our classifier. Now, after training, we can classify the image. So I create this variable, which will be a classified image. So I have named it classified. I use my image. I select the bands, specific bands. And then I use the classify function for images, and I say I want to classify using this classifier, which is our variable that we have just trained here, the classifier that we have just trained. So this is pretty much classifying our image into those 4 classes. And I create a variable for the visualization parameters. So I have classification this. Since my classes go from 0 to 3, right? 0 forest, 1 developed, 2 is water, and 3 is herbaceous. I have minimum of 0 and maximum of 3. And for the color palettes, I have this combination of numbers and characters here. This is what we call a hex color code. So if you haven't seen this, a hex color code is a combination of 6 numbers or characters together. You know, if you do a quick Google here, you know, there's a color picker here, and you can change the color you want and the shade of that color. And here you can see, I'm going to zoom in a little bit, you have a hex code here, which is exactly what we are using there. And so you can pick the hex color code for any color that you're interested in. So Earth Engine accepts these color codes. And what I've done for these specific visualization parameters for this palette, I have basically just accessed these colors that we have defined previously. So here for forest, I went here at the gear icon, and I pretty much copied this color code that I have here. So I copied this, and then I pasted it here. And it's in order, right? So here is 0, which is forest. Here is 1, which is developed, 2, water, and 4, herbaceous. So I just pretty much, again, just copied this code and pasted here in our color palette, so that, you know, we already know that, you know, red corresponds to developed, so I wanted to keep that consistent. And I finally added the classification to the map. So here I have map.addLayer, classified the visualization parameters that I have just defined, and I labeled this cart classified. And I will go ahead and run this. Before I run, I'll just turn off here my geometry import, so the points will disappear from my map, so I can analyze the results better. It'll take a while to load. So you can see that the classified image got added to the map. We can see, for example, the sea is all blue, so the classifier did a good job classifying here the sea as water. Whereas we can see here, there's a, you know, probably a lake. Yeah, there's a lake here. And you can see that was also classified as water, so this is good. We can see, for example, the river here. It is also more or less being classified correctly. Well, it's pretty, now that I zoom in, it looks pretty good, right? But then for herbaceous and urban, for example, we can see that there's a lot of confusion. So I'm gonna go here to Milan. So all the city areas should be classified as red. And then we have this dark orangish color for the herbaceous. And you can see that, for example, here, I'm pretty sure these are agricultural fields, so they have herbaceous vegetation, but it's, you can see it's super bright. So some of it is being classified as developed. So there are some misclassifications as well. Here we have, for example, this is probably also a agricultural field. It doesn't look to me like a water pond or anything, but it's being classified as water, right? So there are some misclassifications in this first attempt to classify this image. But for having just 100 points, it's doing a fairly good job. We can see all the forested area here. So all of this darker green area, we can see that, it's being classified as forest. This is our first attempt to classify. And now that we see there's some misclassifications, we'll also work with random forest. All right, so now that we have tested the cart classifier, we can also go ahead and test a new one, which will be the random forest classifier. So in our checkpoint, I'll copy lines 73 through the end and paste in here in our working scripts. And you can see that it's pretty much the same process here. We'll train a classifier, classify the image, and add it to the map. The difference here between cart and random forest is that for random forest, we need to define the number of decision trees that we want. So again, random forest is contains more than one decision tree. So here, for example, I'm defining 50 decision trees for this classifier. And then here is the same thing. I'm training it with the training data. I say the class property is the class property, and I'm using these prediction bands. And then down here, I create this new variable, random forest classified, where I'm pretty much applying the classification to my scene. And I'm adding that result to the map. So I'll go ahead and run this, and let's quickly scan and compare the results. So this is the card classification, and on top of it, the random forest classification is being added. So at this very high level, look at it. I can notice, for example, I'm just change the transparency here really quick. You might not be capturing what I'm capturing. But for example, here I see this forest patch in the card classification that random forest eliminates it, so it classifies into something else. I'm just going to quickly check it out, what's happening. So here's the card classification for this area, and it's all forest, taking a while to load. And I'll just quickly look into the background image here, and we can see that it is mainly agricultural fields, these croplands. There's some image artifacts, I would say here, like atmospheric correction that was not entirely successful, it seems. But if you look at the random forest classification, this is not the case anymore, right? So random forest was able to better classify this entire area, right? So we already see some improvements here. Let's see another example. Turn this on. So we're doing this just visually, right? Just trying visually to see if it's doing a better job or not. But next week we'll look into accuracy assessment. We're actually gonna quantify the classification quality. So instead of visually inspecting like this, we'll have a number at the end saying the accuracy of the classifications, and that way it's more easier to compare which classifier is doing better and also which classes need improvement. We'll talk about that next week. Here as well, you see some areas classified as water by the cart classifier. The random forest classifies it as herbaceous. And let's look at the scene. Yeah, these are pretty much, I'll just quickly see the satellite imagery here at the bottom, but these are, yeah, croplands, right? There's no water beneath it. So random forest is also better classifying, removing this confusion between water and herbaceous. I think also like just the river in general is being better classified. Let's see if it's pretty much the same here, except these really thin parts of the river right here are more delineated by random forest. So this is cart and this is random forest. So it seems that, I think most of the examples we've been seeing here are related to the water class. Let's quickly take a look at Milan, because we saw that there was a lot of confusion between herbaceous class and urban and the developed class. And we can see here a little bit more areas being classified as urban by random forest, so maybe that's a little bit of improvement. And yeah, again, the water part, random forest is doing much better. So this is a water pond. These are also water pond. We can see through here the things. I guess it's a man-made water reservoir or something. And we can see that random forest picks that up pretty well, while carts does not. So overall, random forest seems to be doing a better job. And now that we have finished with these two supervised classifiers, we can try unsupervised classification. If you want to know the rules behind your classifiers or supervised classifiers, we'll add here 2 lines. The first one will be classifier, which is a cart classifier variable dot explain, and we'll do the same for the random forest, which is rf classifier, and we'll use this function explain from Google Earth Engine that will outline all the set of rules that the classifier defined after being trained. So we can see here the result is a dictionary. If I open this first one, which corresponds to the cart classifier, we have here some information about the classes, and down here we have the decision tree information. So we have one decision tree, and we can notice, for example, the set of rules used. So here for band 1, if a pixel value of in the band 1 is greater than this certain amount of value, it then follows this classification rule. So it is here, it's a little messy, but you can access your decision tree using the explain function. The same happens for random forest classifier, but we can see that, for example, random forest will have 50 elements under trees because we have 50 different trees in this random forest classifier. So here 0 is the first one, we have the entire decision tree here. Here 1 is the second decision tree, 2 is the third, and so on until we reach the 50. So the explain function will outline all the set of rules that the classifier defined after being trained. Here we can also access the importance of each band as well.